Hey there. Today we're going to talk about Dalton's Law of partial pressures. The first question is, when do we ever use this in real life? There's a couple of times that come to mind as an example. One might be when they're analyzing atmospheric conditions or how much smog is in San Francisco or any kind of atmospheric problem they might have. Otherwise, they could use it in manufacturing. So when they're making silicone chips, they make that in an inert gas atmosphere, and they have to very carefully control the air around the whole manufacturing process so the boards don't oxidize. So that's two examples of where they could use that, but there's other examples. Let's see if I can slide this over. Yay! All right, so here's our problem. This problem looks a lot like the problem that we're going to do on the sheet that I gave you, but the numbers are all different. So this is the example on how to use this. So first I'm going to visualize what this problem is saying. The whole visualization is we've got some gases that are in these containers and they're joined at the top, and the stopcock that they mention is this little turnkey at the very top that will release these pressurized containers to equalize. So in this one we have carbon dioxide, and we've got 5 liters at 4 atmospheres. We have oxygen in the center where we have 3 liters at 6 atmospheres. And here we have hydrogen, 2 liters at 3 atmospheres. So when we release the pressure and let the whole thing equalize, first of all, what is the total volume? So total volume, we just add up our literage. So that's 5 and 3 and 2 is 10 liters, and we're going to come back there in a minute. So in order to find out a partial pressure, you know, when gases are released here, they're going to take all the gases and that CO2 will come out, and there'll be some CO2 in here, there'll be some CO2 here, there'll be some hydrogen in here and some hydrogen in there, and the oxygen is going to go everywhere. That's just the way it happens. So partial pressures. They're pretty easy to figure out. So for example, CO2, we've got our 5 liters at 4 atmospheres. We multiply them together and we divide by the total liters that we have. And that's going to give us a partial pressure. Doesn't this look a lot like the dilutions equation? I was just really wonderful when I was putting this together going, I've seen this before. So oxygen, we do the same thing. It's 3 times 6 divided by 10. And there's the answer. And there's hydrogen gas. It's 2 times 3 divided by 10, 0.06 atmospheres. So partial pressure is, of course, atmospheres. But now we can add up our partial pressure to get the total pressure in the entire apparatus. Pretty groovy. So it's 4.4 atmospheres total. So now, if you might want to take a minute to jot all of this down, then when I move this board and go to the next part of the problem, you'll have these numbers in front of you. Otherwise, you won't. So here we go. Whee! So what is the mole fraction? That's our new game. Mole fraction is symbolized by the X, fraction, X, with a subscript of whatever gas we're symbolizing. So this is an easy operation where we have partial pressure over total pressure. So the partial pressure of just the CO2 is the 2 atmospheres, its partial pressure, over the total partial pressure, 4.4, gives us 0.45. Look, no units. Actually, they've canceled the units out, and so a mole fraction is just a naked number, as we like to say. So, there we are. Oh, you're not going to fall? So now we're going to apply liquid water to our apparatus, and when we apply the liquid water, water vapor happens just because it's liquid and the splashing. So you got to add the vapor pressure of the water. Now, there's charts and all kinds of lookup stuff to water vapor. I think our problem just simply gives you the water vapor pressure. Most of the time they're going to give it to you in some temperature. You look up some temperature and some pressure and then do all your conversions, like they'll give you 75 degrees Fahrenheit and 22.4 millimeters of mercury, and then you convert just the mercury part because we want atmospheres. So our vapor pressure of water at 75 degrees Fahrenheit ended up to be 0.03 atmospheres. So that's what we move to the next slide with. And so we have we're adding our water vapor pressure to that original equation. So our original total was 4.4. We add our 0.0295 atmospheres, round it up. I actually rounded this properly because there are 3 significant digits here, so I kept 3 significant digits there, so it's all happy. So I have done the partial pressures for each of the 3 gases originally, plus the vapor pressure for the water. So here are our numbers. So here are our new vapor pressures for all of our species of gas. And really, that is all there is to Dalton's Law of partial pressures. This is really an overview of Dalton's Law. Gives you a little bit about figuring out partial pressures, a little bit about that mole fraction. So that is it today. Thank you very much for watching.